Hey there! So there is one more service I want to talk about that can be used to ingest data to our BI solution, namely Azure Synapse Analytics. That's a big service. It's a huge part of the exam, so you have to know it quite well. And today, I'm not alone. I have a company of this little guy here, this Lego minifig. Why? Because we'll be making use of Lego datasets. We'll be working on this data together with Synapse. So let's get started. All right. So Azure Synapse Analytics. That's the topic for today. So actually, let's start writing it down, what this service is. So Azure Synapse Analytics. A big service. So what's the origin of this beautiful service? So basically, when you think about a data analytics solution, you will notice that there are various stages, various phases that we work with our data. Like first we've got to ingest it, then we've got to transform it, maybe store in some kind of a database, and so on. And previously, developers had to use different tools, different services, depending on the phase of the data lifecycle. And they had to switch from one service, one tool to another, change the context quite often, and that wasn't the best developer experience. So what Microsoft thought would be a great idea would be to combine existing services used for data processing into this one big service called Azure Synapse Analytics and make it available from a single place. So Synapse is just an umbrella for some of services. And in theory, developers would have to use only this single service. They wouldn't have to switch to another one, because everything should be contained within Synapse. At least that was the theory. And now, if you are into Microsoft Fabric, you might notice that, hey, but isn't it the same thing that it is happening right now with Microsoft Fabric? That they are incorporating various components into Fabric to have this single UI for developers? And the answer is, yeah, it's pretty the same concept. So why? Basically, my personal belief is that Synapse, well, it didn't work that well at all. Its adoption rate wasn't that good. It wasn't used that often as Microsoft wanted it to be. At least that's my opinion. Maybe there's something more about it. And actually, there is even a discussion happening whether Synapse Analytics is that service, because everyone now will go into Fabric. And let me show you something. There is this nice blog by Paul Andrew where he discusses exactly this. Is Synapse Analytics dead? And I encourage you to go through this article because it's very good. But anyway, whether it is that or not, for the DP203 exam, you will have to know quite a lot about Synapse Analytics, even if you are not going to use it at all in your real life. For exam, it is a must. All right, so what is inside Synapse? So as I said, Synapse is just an umbrella that combines various components inside. So the first component that I want to talk about is called pipelines. And as you will see later on, pipelines, it is simply data factory. What they did was to grab the code of data factory and just incorporate it into Synapse and rename it to pipelines. And actually, that will be the topic for today, because today I want to focus on pipelines, because that's the service, or that's the component of Synapse that is used for data ingestion, and will be still ingesting data today. Then once the data is ingested, we will usually have to transform it somehow, clean it. And for that purpose, Synapse has yet another component that is called Spark Pool. Spark Pool. So that's the stuff that allows you to write your notebooks using PySpark that is able to process your data in an efficient way, even if it's a huge amount of data. And we'll cover that in future episodes, so don't worry about this. Then apart from those Spark pools, we've got two flavors of SQL pools. So we've got serverless and dedicated pools. And the dedicated SQL pools is mainly used for data exploration, for checking what you have in your data lake, how the data looks like, what you can do with it, and for some other use cases as well. On the other hand, this dedicated flavor, it's a good old heavy data warehouse, which uses this massively parallel processing concept to process data in case we've got a huge amounts of this. And each of those components will be covered by me in a separate episodes. Today, let's just focus on pipelines. And one more thing before we move forward is Fabric, because I mentioned Fabric already, that actually it's a successor of Synapse Analytics. So how does it relate to DP203 exam? And initially, I thought that, well, we can use Microsoft Fabric for data engineering. So it will be a natural move from Microsoft to incorporate it into DP203 exam scope. But actually, they did it in a different way. Because what they created was a new exam, DP600, implementing analytics solutions using Fabric, which is in beta right now. Which means that right now we have two exams. We have DP203, which is all about data engineering on Azure, like using Synapse, ADF, Data Lake, Stream Analytics, and so on, without Fabric. Because for Fabric related stuff, we have this dedicated DP600 exam, which basically is all about Fabric, including data engineering using Fabric. So from your point of view, it means that right now you don't have to care about Fabric at all, at least from DP203 exam point of view, because it will not be included into it. Of course, in the future, probably you will want to know a little bit about Fabric, and fortunately, a lot of concepts I'm talking about right now can be applied to Fabric as well. But that's something for the future. Today, let's focus on Synapse and pipelines, which is Data Factory rebranded. So let's start with provisioning a new Synapse workspace, and then we'll use it to ingest some data. This little guy will help us. All right, so let's create a new Azure Synapse Analytics workspace. So let's create it. In my DP203 resource group, let's give it a name. Synapse DP203 table demo or something. Region, let it be West Europe. And the important thing is that Synapse workspace, it requires a Azure Data Lake then to be available, because it uses it to store some metadata. And we have two options here. We can either reuse some existing data lake we already have, or create a brand new one. And I will follow the second approach. I will create a new data lake just to have this data separated, so you will be able to clearly see what was stored in this data lake by Synapse. So let me create a new data lake. So Synapse adls g2 table demo1 or whatever. As always, in case of storage accounts, the name has to be globally unique. So that will be a new storage account created, data lake. And then we have to indicate, all right, what file system inside of this data lake should be used by Synapse. And please note that here they use still the old name file system. And simply file system is just a container, so this top level object. So let's create a new container file system called Synapse stuff. And that's it. Let's go with the default settings. And let me create this workspace. Hopefully it will work just fine. Now, it will take a few minutes to provision. So let me make a short break and I will be back once it is ready. Alright, so the Synapse has been provisioned. So let's open it. The Synapse, where is it? Let me find it. Synapse workspace. Come on, Synapse, that's the one. So let's open the UI and see how it looks like. So like in case of Data Factory, we've got Synapse Studio. For Data Factory, it was called Data Factory Studio. And you'll see that it looks pretty similar. So the user experience should be familiar to you. All right, and as in case of Data Factory Studio, on the left-hand side here, we've got those various tabs which we can use to work on different parts of our data analytics solution. So we've got this data tab, which allows us to work with SQL databases or lake databases. I will cover that in a second, or maybe not in a second, in future episodes. We have this develop tab, which allows us to create SQL script to query our data. We have a custom query language script, which has a different use case. We can create a notebook to work with this Spark pool. We can create a data flow, something similar we have in Data Factory that can be used to transform data. It doesn't mean that we should use it, but there is such possibility, and so on. The most important part for today is this integrate tab, because here is the place when we create our pipelines. And that's what we want to do. Let's create a pipeline. Let me hide this stuff. And actually, this UI, it looks pretty much as Data Factory Studio. And that's the case. Because pipelines in Synapse and Data Factory, they share the same code base. And 99% of stuff is the same in both cases. So if you know how to work with Data Factory, you should be able to work with Synapse pipelines in no time. There are some differences between these two services. There is a documentation that explains them, and I will provide a link to it. You can find it in a video description. But today, let's focus on those pipelines and let's ingest some data. Alright, but what data we'll ingest today? And well, let's work on this Lego dataset. So basically, there's this super cool site called Rebrickable, which allows you to check what you can build with the Lego sets you already have. And it allows you to see those official Lego sets and the community created ones. So it is a really cool website. So if you're into Lego, I strongly encourage you to check it out. What is also important in our case is that Rebrickable exposes an API. So let me find it. Rebrickable API. So it has an API that will query, and then using this API we will be able to get data. And today I want to focus on this data, on minifigs. this is a minifig. So what I would like to do today is to query this API and get a list of all minifigs that were released by Microsoft, by Lego company, not by Microsoft. We'll use Synapse to ingest this stuff, and that's the task for today. And because Rebrickable is a brand new data source for us, so let's actually revisit the episode when I was talking about what questions we should ask when starting to work on a new data source. So let's go for this list and let's check whether those questions make any sense. Alright, so let's go for it. So the first question is, alright, so what kind of data are we working with? Is it a database, file, API? And obviously we know from documentation of Rebrickable that it is an API, so that's clear. It is an API available over the internet. Actually, if we scroll down or go through this documentation, you will see that it is a REST API, which means that it follows some standard patterns that are widely used by various APIs around the world. So that's good for us. Alright, so the next question is it cloud or on-premises data source? Because it might impact the integration runtime we will use to connect to this data source. And in our case, this Rebrickable API, it is a cloud data source. It is exposed to the internet. So we can use the integration runtime that is automatically provided by Data Factory or by Synapse. This Azure integration runtime. It will work just fine. Then, is it a pull or push approach? So mainly, is it us, our solution that is connecting to the API and grabbing the data? Or is it the source who somehow pushes the data to us? And in our case, it will be us calling the API. So it will be a typical pull approach. Then, is it a streaming approach or batch processing? And in the case of this Rebrickable API, it is obviously a batch processing because we'll be connecting to it, let's say once a day, and we'll get a list or get a data of all those minifigs. So it is a batch processing for sure. Then about ingesting schedule. Do we have to worry about it not to disrupt the source? Not really. It's a publicly available source. So if we can query it at any time we want. We won't do any harm to the source. So that's fine. Obviously, when deciding about the ingesting schedule, we have to think about when this data should be available to our end users. So, for example, if they come to work at 8 AM and they want to have this data ready, then we should schedule the ingest process and data processing maybe somewhere during the night. But in our case, it is fine to run it, let's say, every 6 AM, every day at 6 AM. Then, is this data source under development? How often this API changes? And this is a valid question. And you can see here in the documentation that we have two versions of the API, v2 and v3. We want to use the latest version, v3. And here, there should be somewhere a changelog. And as you can see, the last change was made in 2020, so a few years ago. So for sure, there is no active development happening on this API. So we are fine to use it. And we can forget about changes that might break our processing. Well, maybe not maybe not forget about it, but we don't have to worry that much about it because there's a low chance that something will be changed in the near future. Alright, then, how to connect to it?
what IP port protocol, if it is used, or what URL should be used. So this information can be retrieved from going through the API documentation. So basically, here they give us an example how to connect, and you can see that in this case they connect to this Rebrickable.com URL, and then they append an API endpoint. In this case, an endpoint that gets all colors that are used by Lego. And if we scroll down the documentation, you will find a list of all endpoints. So in our case, because we want to grab minifigs, we'll be using this API v3 Lego minifigs endpoint combined with the Rebrickable.com base address. So that's our URL. So that should work just fine. We will see in a few minutes. Alright, about networking. Do we have to care about firewall? Not really. This API is publicly available. Basically, it wouldn't be very useful if it would be behind a firewall, because it would limit its usage. And the goal of this Rebrickable API is to make it available to everyone who wants to connect. So from networking point of view, we should be fine. Then security. So how are we going to authenticate and be authorized to use this API? Can just anyone query this API, or should it be somehow secured? So again, if we go through documentation, you will find here this authentication section. And what they say is that every call to this Rebrickable API needs some kind of a key. This is an example. So this is some kind of a string that has to be passed as a HTTP header called authorization. And the syntax is like this. It has to be a word or a value of string key followed by the actual value of our API key. Alright, but how do we get this API key? And I did the homework, and actually it can be obtained from your profile inside Rebrickable. So basically on this site you can create your own account for free. I did this and I'm already logged in as stable on Azure. And if I go to my settings, I believe, then here in the API section you will find your personal authorization key that you have to include in every request to the API. And already you should notice that this API key is a kind of a secret that you don't want to share with anyone because it identifies you. So me showing you this value is a security incident. I will have to regenerate this key after recording this video. But anyway, we will be using this key to connect to the API. Alright, so let's move forward. So let's create a proof of concept to verify connectivity. And actually, it won't be a proof of concept. We'll create the actual solution right now. So let's do this. So let's go back to our Synapse workspace. We have a pipeline. Let's call it get minifigs from Rebrickable, like so. And we have to start designing our pipeline. And what we want to achieve is to basically copy the data from Rebrickable API and dump it into our data lake. So first of all, what I want to do is to go to my data lake that we've been using so far. It was stable data lake demo, that's the one. And let's create a container for Rebrickable data. Under role, let's create new directory, Rebrickable, and then under it, let's create a directory for minifigs, because that's what we want to ingest today, this dataset. All right. So we want to copy data, and you should remember that we've got this wonderful activity called, well, copy data. That is super flexible. It allows us to connect to various data sources and various targets and just copy the data from the source to target. And hopefully it can be used in our case as well. All right, so let's give it a name, like get or copy minifigs from Rebrickable API, like so. And we've got to define a source and target, or sink, how is it called here. And you should remember that in order to connect to some data source or destination, we've got to create a linked service. Because linked service is basically a connection string. So let's create a linked service. All right, so to do this, let me go to the Manage tab, the same as in case of Data Factory. You see that they are pretty similar pipelines in Synapse and Data Factory. So let's go to Linked Services and let's check, just maybe, there is a connector for Rebrickable. No, there isn't, unfortunately. But it was worth checking it. Obviously, neither Data Factory nor Synapse is able to provide a connector to every API out there, but we know that this API is a REST API. So for sure, those pipelines can connect to a REST API. So let's try to do this. So let me type REST, and yep, we've got this REST linked service type that we could use. So, oh, come on. So let's do this. Let's use a REST linked service. Let's give it a name, like Rebrickable minifigs REST linked service. All right. Then, integration runtime. We know that this API is available publicly, so we don't have to bother with self-hosted integration runtime or the runtime with managed VNet. The one that is provided out of the box should work just fine. Then we've got to provide this base URL, so Synapse would know where we want to connect to. And based on the documentation, we should know that it is this Rebrickable.com address that we should use, like so. Then we have to authenticate somehow, and we know from documentation, and again, reading documentation in case of ingesting new data sources is super important. And this documentation provided by Rebrickable is pretty good. It's not always the case, to be honest, but in this case it is pretty good. And we know that we have to provide this authorization header to be authenticated. The issue is that none of those methods provided here allows us to provide this header. So in this case, we have to use anonymous authentication type. And then when making a call to this web API, we'll provide a header. So let's verify if we can reach this Rebrickable.com website. We can, great. So we have a linked service. So let's move forward. All right, obviously, we also need a dataset when we want to connect to some data source. So let's create a new dataset. All right, but what type? Obviously, again, it will be a REST dataset for sure, because we are connecting to a REST linked service. So let me give it a name, like minifigs REST dataset, let's indicate that we want to use our Rebrickable REST linked service, like so, and we are done. So we have a dataset created, which knows that we'll be connecting to some REST API. All right, but we've got to obviously configure it. But we'll get to it in a second. Oh, actually, let's do it right now. So what do we have to do here? So let's go to this dataset and let's fill this relative URL value. So basically, the combination of these two, base URL and relative URL, will tell ADF or Synapse to what API we want to connect. And again, we'll get this value from documentation. So if we scroll down to Lego minifigs, it is this particular value we want to grab, API v3 Lego minifigs. So let me paste it. Let's remove this get phrase, and that's it. So that's our address, rebrickable.com/API v3 Lego minifigs. That's what we want to use. All right, so that's our source site. And on the sync side, well, again, we've got to create a linked service and the dataset. So let's create, this time, let's start with a dataset. So again, we know that we'll be saving this data to a data lake. So let's use a data lake type of a dataset. And then we've got to indicate, all right, but what file format will be used? And that's something we've got to check. So how does this API return the data? Hopefully, let me grab the authorization key. This API allows us to try the API and see what would be returned. So what I did was to paste this my API key into this API documentation site. And here we've got this try it out button, which should make a request to this Lego minifigs endpoint and show us the response. And we can see clearly that it is a JSON. We've got some results stored as a JSON, which means that again, we would be storing this data in a data lake as JSON. So we've got to choose in a dataset format, we've got to choose JSON, like so. Let me give it a name like minifig JSON dataset. Then a linked service. We don't have a linked service in Synapse to my data lake, so let's create it. ADLS Gen2 linked service. But before we do this, obviously we'll have to grant Synapse Workspace access to my data lake, because right now it doesn't have this access. So if I would like to test the connection, it will obviously fail. So what do I have to do? Well, let's go to my data lake. That's this typical data lake demo data lake. And let's take a look at its access control. What kind of role assignments are already in place? And we can see that, well, we will need this storage blob data contributor role that grants us read and write access to the data on a data lake. And we have this group called data lake contributor that is granted this role that we need. So what I will do will be to simply add an managed identity of a Synapse Workspace. And yes, Synapse is yet another service that has its own identity. And I will add this identity to this Entra group. So let's do this. Let's go to Microsoft Entra. That's a place where we define our groups. Let me find this data lake contributor group, and let's see who is already added to it. And we have two members. That's the managed identity of Azure Data Factory, and that's the user we used from the Logic app. So here I will just add a managed identity of my Synapse workspace. So let me grab a name of the workspace and let's add a member. Like so. It should be found. Yes, that's the one. If I refresh it, I now have 3 members. So I added a managed identity of this Synapse workspace, which means that pipelines will be able to connect to my data lake and read and write data to it. Alright, so let's finish configuration of my linked service. Obviously, I don't want to use access key for authentication. I want to use system assigned managed identity. That's what we've just defined. And let's indicate which data lake we want to connect to. And it was Tibble data lake. So that's the one. And hopefully it will work already. Yep, connection was successful. So let's create a linked service. And then we've got to indicate in our data set where we want data to be saved. And let's just browse it. I want to store it inside raw container, then Rebrickable minifig directory. And I want a file to be called minifig.json. And right now I cannot import the schema from this file because it doesn't exist yet. Alright, so we are done. Let me publish all of this stuff so I wouldn't lose it in case of any issues. And please note that right now I'm working in this Synapse live mode, which means that my workspace is not integrated with Git repository. But that's fine for right now. So let's wait for these changes to be published. Alright, so the changes have been published. So let's debug this pipeline and let's see if it works. Usually it doesn't work during the first run, but maybe this time it will. We'll see. Let's just wait a few seconds and maybe some file will be created in our data lake. It failed. But why it failed? Let's just take a look at the error message, which means that authentication credentials were not provided. And yes, that's true. We forgot to actually use our API key. So we created this linked service and a data set. We chose anonymous authentication type, but I forgot to provide this authorization token, which contains our API key. So how to do this? Well, let's get back to the documentation and how they want it to look like. So we've got to create a new HTTP header called authorization. So let's do this. Let me grab a name of the header. And inside our source configuration, here we can see that there is a place to add new HTTP headers. So that's the place inside which we can configure this new header. So let's add a new one. It had to be called authorization. And the value of this header was supposed to be a concatenation of word key and the value of our key. Right, but actually let's do this. So let me make it dynamic. Let's use a concat function. And it was supposed to be like this: key, space, and then our API key value. The problem is that I don't want to hard code my API key here inside this copy data activity, because
if it changes in the future, I would have to go here and update it. So it doesn't sound like a good design. But let me publish it. And let's think what we can do about it. And obviously, the natural choice for storing such secrets is a key vault. So let's go to a key vault. Let's find the key vault that I've been using so far. That's demo key vault table key vault, and let's add a new secret to it. So let's add a Rebrickable API key secret. And as a value, let me copy this key and let's add it like so. So the secret has been created. Now the problem is that our Synapse pipelines will not be able to get the content of this secret because Synapse is not yet authorized. But you know that we could use access policies or airbag if we used that access type to get access to it. And here we again have this demo key vault secret reader entra group that we created in the past. Let me copy the name. That is granted get and list secret permissions. So if we add a managed identity of Synapse to this group, it will be able to grab the content of every secret that is stored inside our key vault. Alright, it should work. So let's again go to Microsoft Entra. Let's go to this group that is used to grant access to a key vault. And let's again add a managed identity of my Synapse to it. And right now, the only member of this group is a managed identity of Data Factory that we've been using in previous episodes. So let's add this managed identity. Alright, so right now it should be refreshed in just a few seconds, like so. So right now Synapse will be able to connect to my data, my key vault, and grab all secrets. So not only this Rebrickable API key, but also this data lake access key. And that's the drawback of using access policies, because those get and list permissions, they apply to every secret. We cannot be more granular, at least not in this mode. But for this demo, it should be fine. Alright, so let's get back to Synapse and let's see how we can get this secret from a key vault. And the problem is that, well, we can reference a key vault when we create a linked service. For example, we did this when we were connecting to a data lake. But here, in this authorization header, there is no way to reference a key vault. So how to get it done? Well, let's just Google it. So ADF get secret from key vault. The first link will tell us how to achieve this operation. And I'll just scroll to the most important part. So what we have to do is to add a web activity inside our pipeline. And this web activity will be configured to connect to our data key vault and grab the contents of this particular secret. So let's do this. So let's add a web activity, this one. Let's call it get Rebrickable API key from key vault. And let's configure it in a way that documentation says. So about this secure output, we'll get back to it in a second. So the URL, we've got to provide a path to our secret and then append this API version 7.0. But how to get this secret URI value? So if we go to our key vault, to secrets,
to this Rebrickable API secret, to the current version, here we've got a secret identifier. That's the URI we want to use. So let me copy it and let me show it to you in a notepad. Alright, so that's the value. So how does it look like? So we've got a address of my key vault, then indication of what type of objects I want to refer to. In this case, it is a secret. Then we've got a name of the secret, and the final part is the version of the secret. But in my case, I don't want to lock to this particular version, because in the future, if I rotate the key, I want this URL to be still working, and I want it to grab the latest version. So I will just remove this hard-coded version, and I will use this URL. And we've got to append this API version at the end. So it would be something like this. So let me copy it and let's add it as URL. Alright. Then what's next? We've got to configure the method as a get operation. Makes sense. So that's a get. Then for authentication, we've got to use system assigned managed identity. So again, Synapse will connect to Key Vault using its own managed identity that was just granted the access. So it should work just fine. So system assigned managed identity. And finally, we've got to set the resource to this Vault Azure net address. That's a static value for accessing Key Vault. Let's remove those spaces and it should work. And I want to test this web activity. So let me temporarily, oh come on, deactivate this copy activity. Let me save it. And by the way, take a note that recently they added this possibility to deactivate or activate parts of our pipeline, those specific activities. So right now it is disabled, so it will not be executed. So if I click debug, it will execute just this web activity, and we'll be able to see if Synapse successfully connects to a key vault and grabs the content of my key. And to verify it, I will go into the logs, and here I will be able to see the outputs from this web activity. And if everything went fine, then I should see, yep, the value of my secret. So this 31, E81 and so on, that's my API key that we want to use in the future to connect, to authenticate to Rebrickable API. Now, take a note that this key is stored under this value element inside this JSON response. The issue is that it is available in plain text in logs. So later on, everyone who has access to logs will be able to see the value of my key, which is not a good idea. So how to make it more secure? So basically, in my web activity, what I will do under general settings would be to check this secure output checkbox, which means that all outputs from this activity will not be available in logs. It will still work. The output will be available to be used by later activities. It will just not be persisted in logs. So let me show you how it looks like. So let me debug it one more time, this time with this secure output checkbox checked. And if I check the outputs, then the API key value is no longer visible here. So later on, what I would do would be to rotate the key, so the previous log will no longer store a valid version. But for now, let's just go with the the version we have right now, just to make it faster. So let me enable, oh come on, let me activate, I don't like the UI. Let me activate this copy data activity. Let's connect it, like so. And let's make sure that somehow inside my copy data activity, I will be able to reference the value from this web activity. And it's pretty simple. So let's go to this authorization header. When we have a dynamic value constructed, so instead of this hard-coded value, what I will use? I will simply reference this web activity. And you should remember that the output was a JSON file and the actual value of my API key was stored in the value element, like so. So by adding this .value syntax, I should be able to get access to my API key. So let me publish it and let's try to debug it. And we'll see whether it would work this time. Alright, and it succeeded. Everything is marked in green. Great, so we were able to authenticate. And before we check the results, let's take a look at the logs, especially from this copy data activity. So here I can see inputs, outputs, and some details that tells us what data was processed and how much of it. So let's take a look at inputs and take a look that here our API key is again visible in clear text. So to hide it, what we'll do later on would be to go to this copy data activity and here just secure the inputs. So this API key will not be visible. Alright, now let's take a look at the details of the copy data operation, and we can see that, yeah, some data was read from this REST endpoint, and some data was saved, like 30 kilobytes was saved to our data lake. So let's jump into the data lake and let's see if there is any data available. And there is. We've got this minifig JSON file. So we were able to ingest this data from a web REST API. So let me take a look at it. Alright, so it's some nasty JSON file that is not readable in this form. So let me quickly download it and let me open it using Visual Studio Code, which allows me to format this document so it looks better. Alright, so we can see that, yep, it is a JSON file. We have some metadata here. We can see that there is in total 14,000 of those minifigs available. And here we can see our actual data that was retrieved. So for example, this toy store employee minifig, it has this URL to get its image. So let's see how it looks like. Yeah, so that's the image of this minifig. So we did a really good work in ingesting the data. Almost. Let's take one more look at this data. So we should have 14,000 of those minifig entries, like so. But if I scroll down to the end of the file, we can clearly see that definitely this file doesn't contain those 14,000 minifigs. Why? Because this data is paginated. If we go to documentation, what they tell us is that actually that the data is paginated and there is this next and previous fields available in the result set, which tells us which data page or which URL contains the next data page. And we can see it here. So in the first page, because we just grabbed the first page of the data, we've got this URL that will allow us to get the second page of the data. Obviously, there is no previous page because it was the first one. But it means that we just ingested only a small subset of the data, and we've got to iterate over every data page just to grab those 14,000 of minifigs. Alright, but how to do this? Fortunately, this is quite easy with Data Factory and Synapse pipelines. So let's go into Google and let's find a website for REST connector documentation. So ADF REST API. Not this one, I want to go to REST API connector. Oh, come on, REST API connector. Yep, so that's the one. That's the site that talks about different properties of this REST endpoint that we can use to connect, and we use this. And if we go through the various stuff that is described, you'll see this pagination support site section, which tells us that actually this REST endpoint in Data Factory and pipelines, it supports data pagination. And it supports multiple versions because different APIs, they might implement pagination using different methods. And we've got quite a lot of them supported. Now, in the case of our Rebrickable API, we saw that they use these next and previous URLs. And that's one of the methods that is supported in case of Data Factory and pipelines. Now, I don't want to go through this documentation. I'll just show you how to make it work. And it took me some time to get it right, so don't panic if it doesn't work during the first run. So on the source side of our copy data activity, we've got these pagination rules that we want to set properly. In our case, we can see that inside this next elements, we've got a full absolute URL to this data, which means that just by going through the documentation, we've got to use, and the UI is terrible here, we've got to use this absolute URL option. And because we had this next element, this URL is contained in the next element, we've got to provide it here. And it is available as a part of our body. So that's the configuration that should make it work. So let me publish it. And let's debug this solution. And basically what we did is that this time pipeline and copy data activity, it will check the response it received from API, and if this next element here, if it contains a value, it will automatically go to this address and grab the next data page, and so on, unless there is no more data available. At least I hope it will work this way. So let's wait a second. Alright, and it failed. Something is wrong. So let's take a look at the error. And they say that the REST call failed with error 429. So we'll check this in documentation in a second, whether this type of error is described. In the meantime, let's take a look at details. And actually, we can see that this time our copy data activity read 3 megabytes, and it iterated over, it read 60 objects, which in our case means that it read 60 pages of data, and then it failed with this 429 error. Alright, so let's go to documentation and let's find this 429 error. And we can find it in a response codes, which means that request was throttled. I'm sending too many requests too fast. Alright, and I should send 1 request per second. And actually, if we go back to the questions, we get this question about rate limits and throttling, if there is a limit on the number of requests we can make. And yes, we can see that this API implements this. So you have to introduce some delay. And also, we already know that data is paginated. We know that the data is returned synchronously. So we make a request and immediately we get a data back. We know that it is supported by data factory and pipelines because it is just a REST endpoint. How much data do we have to work with? Well, it's 14,000 minifigs, so it's pretty small, to be honest. And it is always a full load because this API doesn't allow us to get the data incrementally. We can ask for a specific data page, but that's it. So we'll always grab a full data set. Then what data is it? Well, it's a typical master data, right? It's just a definition or a list of minifigs. Is it special in any way? No, there is no confident data, there is no PII data. We can just process it however we want. Historical data? No, we don't have to bother about this. We get the sample data from the API documentation side, and the rest of the questions we can skip. So let's get back to the Synapse and let's try to add this delay to make sure that our requests are not throttled. And fortunately, we've got this request interval property, which tells ADF and pipelines what should be a delay between requests for multiple pages. And that's our case. And by default, it is set to 10 milliseconds. So let me set it to 1000, which means that every request will be sent every second. So it will take more time to iterate over those all data pages, but hopefully we will not be throttled this time. So let me debug it and let's wait for a few minutes and I'll be back in a second once it finishes. Alright, so the pipeline finished. It is green. This time we were not throttled. Let's take a look at details and take a look. We read 7 megabytes of data and 142 data pages. And all of that was saved successfully, hopefully. So let's go to our data lake. Where is the data lake? Let's refresh the view. So previously we've got like 30 kilobytes of data. Let me refresh it. Now we've got 4 megabytes, so much more. So hopefully this time we've got a full data set. So let me download it. Let me open it again in Visual Studio Code. Let's reformat it. And now we've got much more lines than previously. Because previously we got like 800 lines. Now we've got way more. So actually let's go to the end of the file and let's see what the next operation, the next element looks like on the last data page. So let me go up. And this was apparently the last data page because it had null as the next page indicator. So it is a proof that indeed we ingested all available data pages. So that's great. And let's try to find some minifig like Gimli from Lord of the Rings. And let's check how it looks like. Yeah, so that's the Gimli.
cool dwarf from Lord of the Rings. So let's take a look at this data one more time to see how it looks like. So basically, first of all, we still have this metadata that at the end we don't care about. So later on we'll have to clean this data, transform it to get rid of this stuff, because what we care about is this, those results array. Next, if I collapse the data, what I can see is actually that every data page, every request to a specific data page was saved as a separate JSON object, and they were just concatenated into this single JSON file. So for sure, later on, when we'll be transforming the data, we'll have to work on this file to make sure to process all of those data pages and remove the stuff that we don't care about. But apart from that, it was a pretty good example of using an API to grab a data. Alright, so let's summarize. So Synapse is just this unified tool that combines different components under the hood, which should make a user experience for a developer better. So at least in theory, developers should be able to use only this single service to work on any phase of the data analytics project. At least that's the theory. And today I showed you that the pipelines component inside Synapse is basically the same stuff that we saw in case of Data Factory. So if you know Data Factory, you should be able to work without any issues in Synapse pipelines, because there is almost 100% parity of features between these two. Now, obviously ADF tools, this CI/CD solution created by Kamil Nowinski, it will not work with Synapse pipelines because it was created for Data Factory in mind. But apart from that, most of the stuff will work just fine. And that's it. So it was the last service I wanted to cover that we can use to ingest the data. So in the next episode, I will summarize the ingest phase, and there will be a challenge for you. So let's see how it works, and see you next time. Thanks for watching and take care.